If you have this kind of terminal alkyne means when the triple bond is on corner. It is called terminal alkyne. This can become C minus Na plus. So it can take H plus. Can you observe this? Triple bond was there. Terminal H. This H can be taken up. This becomes C minus Na plus. If a normal triple bond is there, if it is internal alkyne, it will give you double bond. And that too trans type. If there is a double bond, it will give nothing. If there is conjugated double bond, that means double, single, double kind of setup. So it gives you this kind of trans. Middle में double bond आ गया और terminal वाले double bond हट गया, right? So this kind of structure it will come. If you do it, so this is point number 3, point number 4, point number 5. ये वाला भी कैसा है? This is also trans. Opposite side. If it is given with this kind of compound, like CH3, it will convert into 3 double bonds will become 2 double bonds, but double bonds will come like this. You can see it's with CH3. So one is with CH3, another is parallel to it. Okay. Point number 7. If you put this kind of ring and then NO2 kind of setup, then this time you observe NO2 is not having double bond here, nor here. It is having sideways here. Okay. So this is a basic difference. यहाँ पे जो bonds है, आपने देखा 2 bonds sustain कर रहे हैं. So 2 bonds are sustaining. Here 2 bonds are sustaining, but these two are parallel and NO2 is on top. Here these two are parallel, but CH3 is adjoining. Can you observe this difference? Yes. See this thing. And see this part. Can you find the difference in both?
It's like
Yeah, it's like parallel. Okay. So these are 6-7 cases that you should know, right? 5-6 cases. Sorry, 6-7 cases. So 6-7 ही आ जाता हमेशा. So these are 6-7 cases that you should know. Now coming to the mechanism of it. Mechanism भी देख लेते हैं इसकी ताकि थोड़ा आपको और क्लैरिटी मिल जाएगी. एक दो mechanism मैं करके दिखा देता हूँ. But remember, this is very, very interesting reaction. We can go much more deeper and we can dig more, but not right away. Once you understand these things, at least, then we'll go next level and next level, right? So
could you explain the
seventh one. See, when NO2 kind of, this is a withdrawing group, right? And this is a pushing group. So pushing group, we find double bond is like this. Withdrawing group, double bond will not stay here. It will stay here. Okay. I'll show you why. I'll show the logic. I'll take this example only to show the mechanism. Okay. So when I show you example of this, automatically this you understand. And ये आ जाएगा, ये भी समझ में आ जाएगा. ये थोड़ा सा different है, इसको भी देख लेंगे. ये और ये दो चीजें कर लेते हैं. Okay, so we'll do maybe third and we'll do 6 mechanism for Birch reduction. How many of you have started reading Morrison Boyd? Arjun,
Yes, sir.
you are not visible still.
Oh, sir, sorry, I forgot.
Okay. Anyone else who has started reading Morrison Boyd, other things, other sources? Very good. Everybody should read. Okay. Like, don't think like the classes are happening, you should not see. When you study, when you read a book, you get a different type of clarity. It will again enhance this, right? It will not reduce it. It will improve your overall understanding. ठीक है? Is it clear? Can you progress further? चलिए आगे बढ़ते हैं. So let's see these two cases and try to answer. Case number 1. Let's start with this example. Anyone who can tell me why I'm writing CH3, why not hydrogen, Akshay? Why CH3 or something is written, why not hydrogen? That's a terminal alkyne. So what will it do? C minus Na plus, वो तो लिखा है आपने ना. Na will, see, Na will just remove that H plus, that's all, that's the reaction. Okay, that will not be reduction, Birch reduction, that is just acid-base reaction. Check point number 2 of your notes. Point number 2, point number 1, कौन सा था? Point number 2, yeah, C triple bond C. So this is called internal alkyne. Internal alkyne. Reaction is happening with sodium in liquid ammonia. They will write like this, or they can write this. This is not indicating that this or this. This indicates Na with NH3, right? So never think कि ये sign chemistry में or नहीं होता. This is not or. Okay, because I think till this point you're using this as or, okay, A or B. So chemistry में इसका मतलब ये नहीं होता. Chemistry is basically this is a solvent and this is reacting. Now one common rule that you can always apply whenever you are given any metal, let's say sodium as a metal. So metal is very good source of electron. I hope we know from atomic structure knowledge. And what is the amount of energy required to strike off the outermost electron from an isolated gaseous atom? Chinmay? Amount of energy required to strike off outermost electron from isolated gaseous atom? What energy is that? No. Ionization energy. Electron gain enthalpy is ulta. Isolated gaseous atom gaining electron, how much amount of energy is released called electron gain enthalpy. Okay. ठीक है. So this is basically ionization energy we are talking about. Any difficulty in this part? This is ionization energy. So because of this Na electron, what is going to happen? You will write this Na becomes Na plus electron. Now this electron is going to attack here. Whenever electron will attack, we have to use half arrow. Please note down this and draw half arrow. Okay, it's a single electron. It's not a negative charge. It's just one electron, right? So half arrow, and this bond will break completely in favor of this carbon. So bond movements आपको आने चाहिए. So what will you make out of it? If you observe this carefully, can we say due to this reaction, CH3 will be as it is. There is a carbon. Now here I get a negative charge. Then I get a double bond. Then I get a radical. And then I get a CH3. इसमें कोई प्रॉब्लम? बॉन्ड पूरा उधर चला गया, सो नेगेटिव चार्ज लिख दिया. इलेक्ट्रॉन अटैक कर गया, सो एक इलेक्ट्रॉन बना दिया आपने. तो सिंपल थिंग. एनी प्रॉब्लम? दिस structure which is in front of you is known as negative is anion and this is radical. So this is called anion radical formation. इसका एक नाम होता है anion radical. Now in chemistry, anion radical mechanisms are very famous. Arjun, is it clear? So in chemistry, anion radical reactions are very famous. Multiple times it will come. There is something called SI law in condensation. ये 12th में आएगी. It's again this kind of mechanism, anion radical mechanism. There are many more mechanisms like that. Is it clear? Just answer one question. You have across this bond on both the carbons, you have one side negative charge, one side electron. How do you want to keep them? You want to keep them very close or away from each other? As much away as possible, right? So we keep them in opposite orbitals. Okay. We are keeping them in opposite orbitals because we don't want to keep them together. They are all having same charge, right? Electron may be negative charge and that is also minus charge. So this will be the structure. And now this C negative is much more stronger base and this can pick H from ammonia. NH2 minus is out. And we have this kind of formation. CH3, CH, a double bond, CH3, radical. Okay. So what has happened? This is negative. इसको H बोला तो यहाँ पे H आ गया. और अभी भी आपके radical as it is है. Now I'll repeat the same story again. What I've written earlier. Another Na will come into play. Na will give you Na plus plus electron. Same thing. This electron will approach here. Will make it what? Answer? What will it make out of it? Electron अगर पहुंच गया तो it will become negative. This is one hydrogen already available. Now what are you going to repeat? Another unit of ammonia. Negative will pick hydrogen. NH2 minus is out. What's my final answer? C double bond C. H, H, CH3, CH3. Trans compound. This is the complete mechanism of Birch reduction. What you have to understand? You have to understand one, this, and second, this. And if you want to remember one more thing or understand one more thing, you should understand this also. That anion radicals are placed opposite to each other. Is this logic clear? So why these two opposite orbitals are involved for this? What is the source of hydrogen? Ammonia. Tomorrow somebody comes with sodium Nd3. आ चुका है JEE में question. Nd3. D is deuterium. तो मेरा आंसर क्या होगा? अगर आप Nd3 लेके आ गए हाइड्रोजन की जगह पे ड्यूटीरियम, which is another isotope of ammonia, like ammonia kind of isotope with hydrogen replaced by deuterium. So what will be my answer here? This will be D. This will be D. कर लोगे? Because ammonia gives you H and D3 will give you D. Are you okay with this part? Deuterium is 1H2. H is protium, 1H1. Any problem in this mechanism? All of you understood this? Why opposite? This is most important thing. Why opposite? To minimize the repulsion. That is the reason, right? Any difficulty? Any issues? Please ask if you want to say something on this. This is specifically trans. We can't get cis formation here. We'll get only trans. Can we remove? Yeah, please note down. ये पॉइंट में लिख लेना, डी वाला भी, ये पूछा जा चुका है. The source of H is hidden in ammonia. The source of H is hidden in ammonia for this particular question.
Sir, can you move to the left? You're covering the screen a little.
Yeah.
Thank you.
So now you should be open to understand mechanisms also gradually. See, I'm not using very tough mechanisms, but at least basic thing you start listening properly, right? Understanding properly. So gradually आपको एक idea लगता जाएगा, हाँ ऐसे mechanism लिखते हैं. And show with proper bond movements, right? ये इस पे attack करेगा तो ये होगा. It's like a story. ये इधर attack करेगा. So that should be very clear with your bond movements. Don't just run behind the product formation. ये reaction इसका product ये है. We are not supposed to do that. Okay? ठीक है? चलिए. Done, Sanjana? Can I remove this, everyone? Arav? हो गया? Copy छोटी कर ली क्या? Same ही है? चल रही है. Okay. Now, let me ask you only to try, all of you, this question. अब उसी logic से try करो. देखो कर पाओगे? This time you take this compound. What is this compound called? Sham? Very good. So it's called toluene. And you are given this with sodium and liquid ammonia. Product आपको पता है? ये चाहिए मेरे को. कैसे बनेगा बताइए. Try. I will say hint is given earlier to you. Hint is anion and radical should not be close to each other. तो सोच के देखो कैसे करोगे, क्या करोगे. So first step would be Na becomes Na plus electron. Now you have to see where electron will go and attack. किस जगह पे electron जाके attack करेगा? So option number 1, I'm not sure whether it is right or wrong. Let's try. So let's say I take this electron and attack on this position. अब आप बोलोगे सर यही क्यों चूज किया? You can choose anywhere. Okay. That's option 1. Or somebody can say no, I want to attack here. Okay, fine. Both are okay. But we have to start with something. So I'm starting with, let's say, first case. एक केस से हम शुरू कर लेते हैं. So let's take this attack here. What will it become? This is attacked, so this bond will break towards this part. This is negative, this is radical. CH3. Now, negative, single, double. So this negative should move here. And as soon as you move it, this will become negative, double, double, radical. Our aim was to keep negative and radical away from each other. We have succeeded in that, but there's a big problem. The big problem here is CH3 being a plus I group will destabilize C negative. यानी ये गलत हो. This is wrong. So what should we do? We should try some other position. Is it clear, Arav? Are you understanding this logic? समझ के करो. See, organic is like, again I'm repeating, it's like maths. Maths में आप क्वेश्चन सॉल्व करते हो, फिर वैसे 2-4 क्वेश्चन और सॉल्व करते हो, right? With practice you grow. Same thing you are doing here. Now, what is the other position? So we have to change our approach. We have to do something else. तो मेरे पास दूसरा ऑप्शन क्या है? अब बहुत ज्यादा ऐसा नहीं, रैंडम नहीं करना है. सो मैं पहले यहाँ कर रहा था, अब मैं अटैक को थोड़ा चेंज करता हूँ. Let's attack to other position. So I'm just drawing the structure once again. CH3. But this time I will ensure that it should not go to CH3. So again you'll write Na gives Na plus electron. फिर से आपने अटैक करना है. इस बार आप यहाँ पे अटैक करो, यानी उसके बगल वाली पोजीशन, एडजेसेंट पोजीशन, एडजॉइनिंग पोजीशन, राइट? देयर इज अ डबल बॉन्ड, इधर की जगह इधर पे अटैक कर रहे हो इस बार. इज इट क्लियर? सी व्हाट विल हैपन दिस टाइम. इफ यू अटैक हियर, दिस बॉन्ड विल ब्रेक इन फेवर ऑफ दिस पोजीशन. सो व्हाट डू वी हैव? Arjun, is it clear?
Yes,
So
sir.
what will it form? It will form a negative charge here, a radical here, a double bond and double bond here. Anion and radical cannot be together. We have to keep them as far as possible. तो आपके पास ऑप्शन क्या है? आप बोलोगे भाई इसको मैं इधर भेज देता हूँ. बेनिफिट CH3 आ गया यहाँ पे, नेगेटिव चार्ज हियर, रेडिकल हियर, डबल बॉन्ड हियर, डबल बॉन्ड हियर. कंडीशन नंबर 1, आर यू हैविंग नेगेटिव चार्ज नेक्स्ट टू CH3? नो. सो ये वाला प्रॉब्लम सॉल्व हो गया इधर पे. Are you having negative charge and radical away from each other? Yes. So this is the correct transition state, right? Correct intermediate, we can say. Is that clear? Now what to do next? Rest is simple. You will say H NH2. This negative will grab H, send ammonia as NH2 minus. On this position, we have joined one hydrogen. There's a double bond. This is a radical. What will happen next? Na will become Na plus electron. If electron will join here, what will happen to this? It will become negative charge. एक H already आ चुका है. CH3 is here. Then what will happen? It will grab H from ammonia. NH2 minus is out. And the final product is So observe, CH3 is here and double bonds are like this. Had it been NO2, double bond ऐसे आता because उस केस में ये वाला ऑप्शन ठीक हो जाता. If had it been double bond, then minus charge यहाँ पे अच्छा है ना, because NO2 will pull that minus charge. NO2 is a withdrawing group. NO2 will start pulling that minus charge. So minus charge coming to this place is good option. Had it been NO2 in place of CH3. So double bonds ऐसे आते हैं, right? In this case, double bonds are coming like this. Is it clear? Process समझ में आ रहा है? So first you made anion radical, then you gave negative charge H plus, and then you put H, then again radical becomes negative, and then finally you get the structure. Is it clear? Sham, is it fine? Arav? Yes. Chinmay? Akshay? Adya? Sanjana? Everybody? Arjun?
Yes, sir.
So birch reduction सीख गए आप आज? At least basic questions solve कर लोगे birch reduction के? Okay. Now, if I take you into detail, I can take like 2 hours on birch reduction. That's not required right now. So let's go to the next reaction. First, we complete this. Everyone done? Okay. Very important reaction. Exam में आता है questions से. So the initial rules which you have written, please mark it very important for exam. Triple bond, double bond, conjugated double bond, benzene ring. You should know these reactions. Can I remove this? चलिए आगे बढ़ते हैं. So let's come to the next reaction. So hydrogenation is clean and clear. Now you know. Addition of hydrogen halide. I don't think I should discuss this because I have done it earlier with you when we discussed addition electrophilic in much more detail. This part we have done, right? HX ऐड करना तो पता है ना आपको. H ऐड करोगे, कार्बोकेटाइन बना के रीअरेंज करोगे, X माइनस नेगेटिव पार्ट बाद में आ जाएगा. Can you recall? In GOC we have done addition electrophilic reaction check in GOC. Can you recall? So this is the same example. Now sulfuric acid अगर अटैक करना है आपको तो sulfuric acid भी कर लोगे. What is negative part of sulfuric acid? SO3H. Positive part H. एक तरफ H लगा, एक तरफ ये लगा और ज्वाइन हो गया. कैसे होगा अटैक? First, this is electron rich thing. It will go and attack on H plus. Okay. And then plus charge will come. If there is rearrangement possibility, do. Otherwise, you can simply go and attack with the negative part. Can you recall these things you have done? Do you want me to do this again or you are okay? Pakka? Okay. Now, this is important, also interesting. Also, write down addition of alkene. So if a question comes, let's just a quick revision of what I have shown you a few minutes back. CH3, CH double bond, CH2. एक बार कर लो, मतलब कुछ लोगों को देख के मुझे लग रहा है कि वो भी डाउट में है. नॉट वेरी श्योर, सो लेट्स डू इट क्विकली. इसकी बात कर रहा हूँ. याद है? किया है कि नहीं? So what we do in this case? First, double bond goes and attack on plus part. Okay, in this case, where is the plus part? In this case, where is the plus part? So what's the arrangement here? CH3, CH plus, CH2H, and later Br minus will come and attack. So answer will be CH3, CH, Br, CH2H. Similarly, in this case, CH3, CH plus, CH2Br, and then OH minus comes and attack. CH3, CHOH, CH2Br. Next case, CH3, CH plus, CH2, NO. Next case, CH3, CHCl. Are you okay with this? And if I ask a question, CH3, CCH3, 1, 2, 3, 4. What's the answer? So first you'll attack here. CH3, CCH3, CH3, CH plus, this will get hydrogen. This is a 2 degree, will rearrange into 3 degree. यहाँ पे देखो rearrangement हो गया. In these cases, no rearrangement because not required. They are all 2-degree best situation, right? Arjun, is it clear?
Yes,
In
sir.
this case, you will do the rearrangement. After rearrangement, what will happen? It will become CH3, C plus CH3 hanging here. This CH gets CH3 and this is CH2H. Later, Br minus will come and final answer will become CH3, CBr, CH3, CH, CH3, CH3. कर लोगे? देखो H इधर जा रहा है, Br इधर जा रहा है. They are not at the adjoining bonds, right? अगल बगल नहीं, दूर आ रहा है. Is that okay? Because of rearrangement. Please note down all these reactions. Then I go to bromine reaction. Quickly note down. Note करना है? या पता है? You know that. Can I move forward? Anyone willing to write? No? Just write down the last one at least. ये तो लिख लो. Okay, just note down this. One reaction. And mention rearrangements are possible. ताकि आपके एक तरीके से नोट भी कंप्लीट हो जाएंगे. एडिशन रिएक्शन आपने की है. दिस इज एडिशन इलेक्ट्रोफिलिक प्रोसेस. Addition electrophilic process. All right. One hundred. So now maths is or physics and chemistry are pending, right? How's your preparation for chemistry? Next is chemistry. How's it going for chemistry? No, not good. Fine. You want any support from my end in chemistry? Any revision or anything in chemistry? Which all topics? Chemical equilibrium. One तो मेरे को याद है. ठीक है. When can we plan that? Tomorrow can we keep? Tomorrow same 2 to 4 we can keep. Maths class की जगह पे. Maths अभी कर रहे हैं. Maths में बचा भी आपको कुछ या हो गया maths? Maths exam is over, but huh? You can keep chem, no, in place of maths tomorrow. Is that okay? Huh? Same time, 2 to 4.
No other class tomorrow. Yeah. After chem, like, no, and Friday.
No. Just chemistry in place of maths, and we'll do chemical equilibrium revision. So at least your one topic will be clear, right? We'll try to finish it in 2 hours, okay, as much as possible. Okay, I'll not go in like too much into like advanced, but at least we can do a good review, right? Yeah. So that kind of thing we can do whenever like MOT is problem for how many of you? Mostly it is problem for everyone. MOT we can do. Any other topic which you want?
Yeah, just one question we can use that like that.
Can do. Okay. So small things which are needed we can do parallelly along with this.
And I think hormones.
Okay. Thermo what part?
Okay.
Don't say complete thermo. That's not
Just like that last portion. Those
gives free energy wala part. Okay. So we can selectively do certain things. Let's see, right? Chale,
Sir,
let's
so
start.
tomorrow you'll only do revision for school exam?
No, I'm not saying that. I'm saying like I'm doing chemical equilibrium review. You want to attend
Yes.
that?
Yes. Okay.
You have done equilibrium, but you want to review, then you can attend. Okay. Or else you anyway come in morning, no? I'll give you separate work.
Yes, sir. Yes.
Yeah. Any difficulty in this? Any issues? Okay. So now write down this reaction. addition of halogen. So you can see here, double bond X2. X2 is an halogen. Let's say bromine. So it joins opposite to each other. एक X ऐसे join हो रहा है, एक इधर join हो रहा है. दोनों एक तरफ नहीं join हो रहे. So why? And why will it join here? What is the mechanism? All those things you have to understand. So write down addition of halogen. Addition of halogen. Yeah, let's see the reaction. Please note down this compound. So थोड़ा deep में सीखेंगे because मैं दो तीन चीजें मुझे और बतानी है, stereo isomers भी बताना है. So we'll do it in slightly more detail. Last time we have not done in that detail. Okay. So Br2 is polar or non-polar? Arav, is it a polar molecule or non-polar molecule? How do you know it is non-polar? Because both are bromine, no? Like H2. Who all are missing? Adya is also missing. Who else is missing? Akshay is missing. Arjun is missing. Yeah, Arjun normally second में आता है, right? Okay, let's start then. Now write on the heading titration. Titration. Chinmay, Niharika, Sanya, can you hear me? All three of you?
Yes, sir.
All right. So we are left with certain things in ionic. Hydrocarbon we have completed, right? Alkynes we have done everything, right? All the reactions and everything is done. Yes or no? So ionic will complete maximum by this next Thursday class, and then it gets over, right? आपको थोड़ा एक्स्ट्रा जो होगा वो अलग से कर लेंगे, ठीक है? चलिए शुरू करते हैं. So write down acid base titration. क्या होता है titration? Anyone having idea about titration? What is titration? Yes, sir.
They take a really small amount of acid impact in the solution until or slightly acidic.
And what is the purpose of titration? आप बताएंगे, श्राव्य? What is the purpose of titration? Why do we need titration? I'll put it that. Sham?
Whatever that acid is. Then, yeah, so
Okay. Anyone from online? Niharika? Chinmay?
Sir, it's to know the concentration of a solution.
So basically, I'll put it in very simple word. Knowing unknown with the help of known. कैसी लिखे डेफिनेशन है? विद द हेल्प ऑफ नोन, इतनी सी बात है. So knowing unknown with the help of known means what? Let's say you're talking about any titration for that matter. So titration can be of three types. Please write down. Titration can be of three variety. It can be acid-based titration. It can be back titration. It can be redox titration. Okay. These are three types of titration that you come across. Acid-based titration, back titration, and redox titration. So when you talk about acid-based titration, let's say you're titrating some known acid and there is some unknown base and you want to calculate the value of its concentration. This is known, this I want to calculate, or vice versa. Base is known, acid is unknown. That is called acid-based titration. What is back titration? Back titration is basically you are doing certain reaction. Something is remaining. Now you are just titrating it back. Let's say you take some acid A1, react with some base B1. A1 remains. It required some other base B2. Right? This is back titration. So we'll say B2's gram equivalent will be same as A1 remaining gram equivalent. B1 gram equivalent plus B2 gram equivalent put together will be A1 gram equivalents, right? That's how we do the calculation part. So the titration part is governed by a term called gram equivalent. Please write down this word. Gram equivalent. होता क्या है gram equivalent से? Gram equivalent is moles into n factor. It is defined as moles into n factor. अब moles क्या होता है आपको पता है? Everybody knows about moles. What is moles? Moles for any atom is weighed by atomic weight, weighed by molecular weight for molecule, weighed by ionic weight for ions. N factor क्या होता है? For acid, N factor is number of H plus it donates. For base, N factor is number of OH minus it donates. For salt, N factor is total positive or total negative charges it is carrying. Right? N factor is that number. I hope HCl N factor कितना होगा? 1. H2SO4 N factor कितना होगा? 2. ये basic आपको पता होंगे सभी. Right? Any difficulties? Please note down this also. So you'll multiply moles into this, you'll get N factor into moles. This will be gram equivalents. And gram equivalents of two reacting things are always same. Just write on the slide. Gram equivalents of two completely reacting substances are same or equal. ये basically rule है, ठीक है? Gram, इसका नाम ही है gram equivalent. The quantity which is equal for two different things. ठीक है? Is that okay? So gram equivalent is same for two reactant substances. A, B, C reaction करेगा तो दोनों के gram equivalent क्या होंगे? Same ही होंगे. Any problem in this part? Okay. A and B reacting, so gram equivalents क्या होंगे? Same होंगे. So you're reacting A1 plus B1, giving A1 remaining. ऐसा केस बनता तो क्या बोलोगे आप? Remaining A1 requires B2. Okay. Initially, reacting A1 is equal to B1. अब सोचो B1 B2 together लेके आ जाओ तो क्या हो? Total A के बराबर हो जाए. Is that okay? Third thing can be redox. Redox is what? Reduction oxidation cases. So in this, what is happening? You will have some oxidizing agent, or you may have some reducing agent. Oxidizing agent will be reacting with some oxidizable material or oxidizable material. See, everything cannot be oxidized, no? So you should have something which can be oxidized. अभी आप सोचो copper +2 को लेके आ गए आप, बोले oxidize करो इसको. You can't do anything with this. It's already in the highest state. There's no copper plus 3, there's no copper plus 4, there's no copper plus 5 that you can form. So it's like a person standing on top floor of building. You're asking him to go up. Okay. So only way is to go down and to go. Can't go up. Is that clear? So there's no option of going up because it's already on the top. Is that clear? So oxidizable material is required for oxidizing agent, and similarly reducible material is required for reducing agent. कर लोगे? ये पूरी बात समझ में आ रही? So what is titration? Titration is getting, Arjun, please turn on camera, getting
Yes, sir, 1 minute.
known. And what about CPT2? किया आपने CPT2?
Sir, not fully. I finished a little.
Why little? था तो था ही नहीं. And Chinmay, why are you not coming here nowadays for practice and all?
So only for a short while. I'll start coming from tomorrow. Don't worry.
Okay, okay, fine. And आप लोग को भी रुकना है, थोड़ा सा राइटिंग प्रैक्टिस बढ़ानी है आप लोगों की. डिस्कशन हुई है कई बार. अभी एग्जाम चल रहे हैं.
No, it's got only I will start from
Yeah, see, you have to start and discuss with me.
yes.
Just you written some papers.
No.
Start writing papers and discuss. Yeah. Any difficulty in this part? Any issues? So can I remove this if you have written all of you these points? See, one thing is very clear that all of you have a lot of potential, but the potential is not realized. अभी थोड़ा सा चिल मोड से बाहर निकलना शुरू करो. ठीक है, 11th हो गया कंप्लीट. अब आपका दिस इज हाई टाइम. दिस इज मार्च 2026. सो यहाँ से आपका पूरा एकेडमिक जर्नी रीशेप होना शुरू हो जाना चाहिए. ठीक है, फंडामेंटल्स बेसिक अभी आपने सब कर लिए. पूरा फोकस अब पढ़ाई पे होना चाहिए. ठीक है. Can I remove this? Okay, let's start. So in your syllabus there is acid-base titration. Okay, in ionic equilibrium we'll do that first. So let's do that. Acid-base titration. I hope the context is clear. Acid-base titration क्या इसका context समझ में आ गया आपको? Okay. चलिए question से शुरू करते हैं. So take a question. 0.1 molar HCl, 0.1 molar HCl, 100 ml. HCl is a strong acid, all of us know. 0.1 molar HCl, 100 ml is given to you. And you're reacting this with sodium hydroxide, NaOH, which is a strong base. So what do we do in titration? This is known thing and this is unknown thing, right? And let's say we want to check when exactly it will be neutralized. Okay, how many ml will be neutralized? So you know mathematically what will be the number. 100 ml will neutralize ho jayega, right? But let's say this is not given to you. Okay, and you're doing an experiment and trying to figure out when the color change is observed, when the neutralization is happening. You can say that this is the molar concentration of NaOH. That is the titration part. Okay, अब मेरे को एक काम करके बताइए. If 0.1 molar NaOH is given and you are using 0 ml of NaOH, 10 ml of NaOH, 20 ml, 50 ml, 80 ml, 90 ml, 99 ml, 100 ml, 101 ml. What will be the change or what is the pH value of the solution? How will you solve? Let's see one by one all the cases. So what is pH? pH value is defined as, Shravi, what is pH? Minus of H plus. Simple सा formula होता है. Look, लिख लीजिए. Minus of log of H plus is pH. Okay. Try to understand and catch up, right? Everything. So if you have 0 ml of NaOH, what do we have? We have just HCl and that 2.1 molar HCl. Okay, and 0 ml of NaOH. So case number 1 को solve करते हैं पहले. Case number 1. What will be H plus concentration in the solution? Everybody, how much is H plus concentration? You will say 0.1 molar HCl, 100 ml is given. You are adding 0 ml. So what's my answer? 0.1 into 100 divided by 100 plus 0. ये तो 100 ही रहा. So can I say answer is 0.1 only? Okay. कितने लोगों को समझ में आया कि मैं सीधे 0.1 पे लिख सकता था?